Okay, welcome to Module 6.2 on wireless and mobility. This is a short little module here, but it's an important one as well. It extends off of the telecommunications. With the changes in wireless and the mobile devices, we're seeing a radical shift in the way users are connecting with businesses or connecting with each other, with their friends. The wireless century begins with wireless communications such as these personal area networks, which is 30 feet apart. You might know this as Bluetooth. Bluetooth is about, I think, 10 to 15 feet officially, but I think it goes up to 30 feet according to the specification. We want to be able to communicate with each other or with two devices. For those of you who may remember, it wasn't long ago where you could have two computers using infrared as well, would be a form of wireless personal area network where the infrared communication would occur between the two computers. And we could transmit data. Wireless local area networks, you might have this in your house or in your office building where you can just roam around. We have it here at Hofstra, where you roam around and you can connect onto the network. Then you have other ones where you have wireless metropolitan area networks of 30 miles, wireless wide area networks, which is a lot bigger, which includes probably satellite devices as well. So this is kind of what a chart might look like for the span of wireless. It's an interesting little chart, but something that you'll be able to recognize quite easily. This one here is actually very interesting. This is where you have a vending machine. And the vending machine is actually connected to your mobile phone so that you can actually purchase. That's a form of the wireless personal area network. So long-range wireless, the only two wireless technologies are really infrared light and radio airwaves. 6.5 shows you a bandwidth spectrum. It's not really that important. But in terms of the radio versus infrared light, it's basically a fundamental difference between the two. Infrared light requires that you have a clear line of sight between the two. But radio is spanning. The difference is the infrared light can travel for a very large distance. The radio waves need a significant amount of power because it begins to dissipate and it weakens as the further it goes out. In the mainstream, GSM has become, which is the global system for mobile communications, it's become the mobile telephony standard for everywhere in the world except the Americas. And I think part of the reason also is because other countries had adapted mobile technologies a lot sooner. Japan and Scandinavia are two prime examples. Japan because space was a premium, so things that could be smaller, things that could be wireless that didn't require the connectivity are very important. In Scandinavia, you had your Nokia as an example, and Ericsson. These are Scandinavian companies where a lot of the mobile phones and mobile technologies were developed. One of the biggest problems for wireless, though, is security. Because it travels over radio waves, you can access the signal. Doesn't mean you can easily interpret it because it could be encrypted. But it is not that difficult for really eavesdroppers to literally try and grab some information, to grab a device that will allow them to retrieve the radio waves and just start seeing those packets or seeing that information. In fact, you can even download an application called Wireshark, which if you were to connect, you can download it on your computer, and you go to a Starbucks or something where there's a wireless connection that's unsecured, and just run the application. You'll see all the packets that are streaming, and you can collect information. That's actually how they do it. It's called packet sniffing. So there's a lot of technologies freely available on the internet to do this. Radio scrambling and spread spectrum technologies add security. Encryption protects data. But again, you have to know what you're doing. You need an expert to actually be able to say, this is configured, this is how we're going to configure it, and this is what we're doing, and this is how we're doing it. In terms of things like security protocols, you see certain standards asking for wireless security of a certain type. So for example, in our wireless LAN devices, your router, you have multiple levels of encryption. You have WEP, which is the wireless encryption protocol, and WPA, which is another protocol for encryption. WPA is a little bit stronger, and if you're in the healthcare field and you have you understand HIPAA, HIPAA does have a statement. It wasn't too long ago where they weren't sure that you should be able to transmit anything wirelessly, even encrypted. But they had since changed that about maybe I think 4 or 5 years ago, and they had allowed it only if it was a WPA or WPA2 encryption. So this has always been and always will be a major concern. Messaging is a killer app. What we know about this time and time again is that messaging is really the key to why the internet was built. And now we find that there are different ways to do messaging. Either it's instant messaging as like a chat forum, or messaging even in terms of like video messaging, like Google Hangouts is another example, or communicating via your mobile device. It's all about messaging, and it's not about just sending someone, hey, I'm going to be at the store. There are many reasons to do so, to have this type of messaging, because someone may be in trouble, or you're trying to coordinate a bunch of people, and we're seeing that this type of messaging is changing the political landscape. Look at what happened in the Middle East with all the various revolutions that occurred during the 2012 regarding Egypt and Tunisia and Syria and Libya. And messaging was a fundamental piece of that we could send messages very quickly, send them around, and people would get them and then coordinate. We send photos, we send videos, we have video phones, so the applications and the hardware are really converging at a very critical time for a very, very significant purpose. Additional wireless technologies include RFID. There are really two types of RFIDs. They're passive and active. What an RFID tag is, it's just basically providing information about the tag. And the tag may have information about the thing that it's on, say a pallet of computers or a piece of clothing on a store rack. Passive is used because it has no energy source. It's used for smaller distances. And the way RFID works is that in RFID, the sender, if I'm trying to figure out what's out there, I may have a transmitter, and the transmitter actually will send some information. A passive tag will receive that information as an antenna, use that as its power source, and then send back a signal that is received by the original base station. In active, it doesn't need an additional power source. It actually has a power source built in so that it can transmit the information every so often. RFID tags are used for security tags in retail, tags for tolls. You probably all have E-ZPass or know of E-ZPass when you have those. And they're used for inventory pallets and shipping. We can also use them to provide additional information for pallets on trucks, to know what came off the truck, what should be on the truck, and so forth. The combination of wired versus wireless, the appropriate combination, is a challenge for CIOs. And that's what they need to focus on. When should we go wireless? When should we stay wired? What are the security considerations? How much does it cost? And what's the impact to the customer? Again, what's the value to the business? The role of the IS department has basically in telecommunications has three roles. Create the overall telecom architecture, run it, and understand the changes that are affecting the field as it is. How are future changes going to impact the way we do business? No matter what, it's going to be about cost and complexity. It's going to be about risk. It's going to be about security. And CIOs, and really the person in charge of telecom or networking or infrastructure, are the people who are really going to have to make those decisions and bring them up to the CIO. The effective implementation and integration of these technologies is very challenging. It's not a slam dunk. It doesn't just work just because it's there. But again, it needs to create that value. Okay, that closes out this module. We'll see you for the next one.